Okay, so let's take a look at falls. And when we take a look at falls from a height, we're going to be looking at these two equations here, kinetic energy and potential energy. So let's say we have a gentleman here who has a mass of 70 kilograms, and he is going to fall a distance of h meters. So here we go. You can either call it h for height or also called delta d. Okay, so in this example, we're going to have him fall 10 meters, okay, and his mass is 70 kilograms. All right, so we can actually calculate his potential energy up here. So potential energy is the stored energy, whereas kinetic energy is energy of motion. So right the instant he starts to fall, all his energy is potential. Once he strikes the surface at the bottom, all his energy is kinetic. Well, that means that all his potential energy must be converted to kinetic energy. So if we can calculate his potential energy, we know his kinetic energy, or vice versa. So how do we do that? Well, for potential energy, you take the patient's mass, you multiply it by acceleration due to gravity, and multiply it by the height above the ground. So in this case, we have 70 kilograms times 10 meters per second squared, which is acceleration due to gravity, times a height of 10 meters, and that equals 7,000 joules. Joules is the unit that we use for energy. Okay, we can't calculate his kinetic energy because we don't know the velocity when he strikes the ground, because for kinetic energy it's 1/2 mv squared. But we can set these two equal to each other, and that's what we're going to do below. So since all his potential energy gets converted to kinetic energy, we set them equal. So potential energy is equal to kinetic energy. Earlier, we calculated his potential energy to be 7,000 joules, and now we set that equal to his kinetic energy. So kinetic energy is equal to 1/2 mv squared is equal to 7,000 joules. Well, we work that out, and you get v squared is equal to 200. So the square root of 200 is v. That turns out to be 14 meters per second, which might not mean a whole lot to us. So if we convert that to miles per hour, it's 31 miles per hour. So that means that this guy fell about 30 feet, 3 stories, and when he hit the ground right here, he was traveling at about 31 miles per hour. Now, if you really enjoy physics, we can actually calculate his velocity or his speed when he hits the ground without any other information other than the distance he fell. And here's how you do it. We're going to use this equation here. V final squared is equal to V initial squared plus 2 times acceleration due to gravity times the distance fallen. So here's the original equation here. Okay, V final is his final velocity when he hits the ground. Initial velocity is 0 meters per second because he initially is not falling, it's all potential energy. A is same as g, which is 10 meters per second squared, acceleration due to gravity, and his delta d is the same as h, which is the height fallen. So we plug it in here, and you'll notice that the initial velocity goes to 0. It makes our math a whole lot easier. V final squared is equal to 200. Vf is the square root of 200, and you get the exact same result we did earlier. And we calculated this only knowing the distance that he fell.